Hello, I am Mustafa Gurbuz.
And I am Adonay Mahatsente. We are from Tuscaloosa, Alabama, a state that is home to many lakes, rivers, water bodies, and including access to the Gulf of Mexico. Our objective in this project is to help solve the problem of plastics and mainly microplastics, garbage and waste that accumulates deep in the oceans, lakes, and rivers, threatening human health, wildlife, and the environment.
This is the problem that we've gained awareness of quite literally as Black Warrior River keepers, picking up garbage in and around the Black Warrior River basin in Tuscaloosa. We were shocked by the sheer amount of plastic and garbage littered throughout the basin, on land and in the water. It was an eye-opening realization to see that even in just 2 hours, we could collect over 1 ton of plastic waste, and this is just a drop or minuscule amount compared to the amount of waste in our oceans.
There are over 190 million tons of garbage in our oceans. The Great Garbage Patches are comprised of just the visible garbage. Over 70% of ocean garbage is deep beneath the surface, where no sunlight penetrates and it cannot be visibly detected from the surface or using lab environment techniques.
Our project thus aims to clean up the world's oceans using ROV-mounted deep neural network-based underwater laser image recognition. Our ROV has 4 motors for multi-directional travel. It has a waterproof box enclosure in order to house the gyroscopic stabilizer and the Raspberry Pi camera. And the DIY gyroscopic stabilizer helps to stabilize the Raspberry Pi camera from any oncoming wave action. And the Raspberry Pi camera is simply hooked up to a Raspberry Pi, which is then connected to the outside via an Ethernet cable.
Our hypotheses were that lasers can be used to identify objects underwater, that image enhancement techniques can be used to compensate for water-induced blurriness, so that deep neural networks can identify garbage in resulting laser images. Our controlled variables were the location of the environment, type of camera used, wavelength, and polarization of the laser. Our independent variables were the brightness of the sun, distance, object size, direct versus indirect lighting, and the background. Our dependent variables were image quality and object recognition accuracy.
We acquired over 400 images of various object sizes ranging from microplastics to megaplastics at varying distances.
Using single-scale Retinex enhanced images, we were able to acquire an over 90% accuracy rate in 7 different objects, including microplastics.
We intend on testing our low-cost solution in local lakes and possibly in an ocean environment during the summer.